Hello everyone. Today we will solve another example related to reoccurrence relation, and let's talk about it in details. You would need to have more practice regarding this for sure, and let me show you in another example how we can deal with it. By the way, when a sequence is defined recursively, and we ask you to solve a recurrence relation or even recursive sequence, then in that case, it's not possible to give the definition of the sequence as the solution, something like this. If we ask you to give us the final answer for finding the solution for that recurrence relation, then you should define your sequence in terms of a formula. Okay, so I will show you, for example, in this example, that how we can do it and how we can represent the final answer. We already mentioned about this theorem before in the book. In that chapter, we call it theorem number 1, but in the exam we cannot say theorem number 1. You should write the whole thing here. You should write, for example, based on this, we can say that, and continue. What was the theorem about? We said that if we have two real numbers, C1 and C2, suppose that we have such equation. You use these real numbers here, C1 and C2. R is a variable, and this equation has two distinct roots if delta is positive, as we mentioned before. So R1 and R2, we call them the roots of this equation. Now, if this is the case, we can have a bijection. Here we say that the sequence AN is the solution of recurrence relation. See, this is what we are talking about in terms of solution. Then AN, we can write it in this term, which is a recursive format, you see. So here we have the recursive format like that. And then we can say if and only if. It means that both sides, they can imply each other. Like if this one is true, this one is true. If y is true, x is true, and vice versa. So if we have such a recursive relation, then you can have this equation. What is alpha 1 and alpha 2? They are constants, okay? And n here in this theorem, they are non-negative integers. So this one doesn't work, for example, for 0.5, for example. This theorem doesn't work for -1, for example, okay? There are some conversion, of course, we can do and have different theorems which they are talking about in the book, but we are not going through them for our final exam or for this course. Okay, knowing this theorem, let's see how we can deal with this example. We call that the sequence of Fibonacci. We can write it in this format. So recursively, we are defining it, and we call them recurrence relation. So when you want to find the solution for that, it means that you should find the sequence for that to satisfy it. Now, these Fibonacci numbers, we know that for the first and second term, we have 0 and 1. This is predefined. And from n, starting from 2 to infinity, you can use this formula. Now, the roots of the characteristic equation, but how come we know that the multiplication of r and this constant is 1? Because in this formula, you see, here we should have C1 and C2. How did we understand about these two numbers by looking at their recurrence relation. You see here, what's the multiplication of this one? 1. There is no multiplication. It means that this is 1 multiply this. The same situation here. So both C1 and C2 are equal to 1. That's why in the formula here, if you assign 1, you will see r power 2 minus r minus 1 is equal to 0. That's why you have this equation. Okay. Then you will find the roots of that, r1 and r2. You should know how to find. Otherwise, if you don't remember, study the delta method again. And as we said, delta should be positive in order to have two distinct numbers. Now, from theorem 1, it says, in the final exam, instead of saying from theorem 1 we understand this, you should write the whole thing so that we understand from which theorem we are talking about. Okay, now let's see what we can do here. Based on that theorem, now that you found the roots r1 and r2, you can use them here inside this formula. You see, this is r1, this is r2, and we should find alpha 1 and alpha 2 in order to write the final answer in terms of fn. So it means that at the end you are finding a sequence, and you should find the formula for that. It's not possible to say my sequence is this, for example, 0, 1, and you continue. No, you should give a formula for that. That's why I keep repeating that whenever we are talking about solution of a recursive relation or reoccurrence relation, then in that case, you should provide us the formula, not the elements of it. Okay, now we reached this part, and we want to know what is alpha 1 and alpha 2. In order to find them, we should use these two because we know what's the answer of them. If I consider n as 0, the answer should be 0. If I consider 1 as n, then the answer should be 1. So that's what we are doing here. Here, instead of n, if I consider 0, what happens? This one would be 1. Anything power 0, this is 1. This is power 0, this is 1. It means that alpha 1 plus alpha 2 is equal to 0. If I consider n to be 1, then n here is 1. It means that here I will have power 1, which is this parenthesis itself, and this one is equal to 1. So the next thing to do is to solve these two equations to find two unknown answers, which are alpha 1 and alpha 2. You should remind yourself how we can do that, to find two unknown variables from two equations, which is pretty simple. So as soon as you find alpha 1 and alpha 2, then just insert it inside the formula, and there it is. This is your formula at the end. So this part is alpha 1, this one is alpha 2. And by the way, here, look at this part. This is positive, right? It means that here, when you write negative, it means that this one is also included as alpha 2, okay? And this part and this part are the roots, which we called R1 and R2. So I can say this one alpha 1, alpha 2, R1, R2, and R1 and R2 are powered by n. You can keep checking it with the formula here, which is provided, okay? So at the end, provide the solution of such relations here, like this, not the elements of them. So if you guys have any questions, please let me know. Otherwise, I will talk about mathematical relations on Friday.